Hello everyone, I welcome you all to the next part of the chapter Circle, and we have already discussed the terms related to circle and two theorems about the chord and perpendicular. Now we'll be moving forward with the circle through 3 points. So let's see what we will learn today. Okay, so what if you are given certain points? Now, how many circle can be drawn through that? We have to learn about this condition. Now, if I give you a single point, you can draw infinitely many circles because there is no foundation to the radius, right? Single point is given to you, which you can consider as a center. We can even consider as a boundary point or anything. But you can draw the circle of different radius. So, infinite circles. Correct? Suppose P point is given to you. It could pass through P or it could be as a center. Now, infinite circles can be drawn through 2 points too. How? The radius doesn't matter. They just need to lie on circle. Now, if I give you 3 points, 3 collinear points, what does collinear means? They lie on the same line, then no circle can be drawn. Because the line segment could only be possible to pass through 2 points and create a chord. Correct? So, no circle is possible through 3 collinear points. Correct? Now, there is only one circle passing through 3 given non-collinear points. And how is that we can say? Take 3 points A, B, C which are non-collinear. Draw perpendicular bisectors of AB and BC, say PQ and RS respectively. And let this perpendicular bisector intersect at a point O which you would treat as center. So let's see how we would do that. We have taken 3 points. We have drawn 2 line segments. And then we have drawn 2 perpendicular bisectors of AB and BC. And the point at which they cut would be the center of the circle. Because we already know that the chord is bisected by the center line. Correct? So by that we have proved that if we have more than 2 points or 3 points which are non-collinear, then only one circle is possible. Okay? Now, this theorem you just keep in mind and how we have created this circle, because there are various questions asked from this. So we can say that there's a unique circle passing through ABC, and if ABC is a triangle, then by theorem 10.5 there's a unique circle passing through 3 vertices. Okay, so the circle is called the circumcircle of triangle ABC. Since triangle ABC is encircled by the circle, so it's called circumcircle, and its center is called circumcenter and radius is called circumference. Correct? Because triangle is inside. Now, you're given an arc. Now you have to complete the circle. So how you would do that? Just see. You have given an arc P and Q. Okay. So this arc you have been given. Suppose. Okay, just don't judge my drawing. The drawing is already given to you. I'm just explaining you the steps you need to do. Suppose this PQ arc is given. So what I did, I took any point R randomly. Okay, same here. And I just joined PR and RQ. And rest is the history. We have already learned how the 3 non-collinear points leads to one and only one circle and how we need to draw that. How we need to draw that? I hope you remember. There's 2 line segment. We just need to make perpendicular bisector of this. How we would do that? Just take an arc from P. Okay. And then from R. And similarly of the same, don't change the radius of the arc. So this is perpendicular bisector. Now for RQ, similarly, from R, keep your protector and draw an arc here and here. Okay. From Q, just cut it here and then join it. Okay. So the point at which both the bisectors intersect would be the center of the circle. And OP or 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 OQ being the radius. All 3 would be equal. Just complete the circle. So this is how you will draw the circle with the R given to you. Okay. Now, the next topic which we're going to start is equal chords and their distance from the center. Okay. Now, AB is a line and P is a point. Since there are infinite number of points on a line, if we join any of these to P, we'll get infinite many line segments. P, M1, P, M2, PL. Okay. So there are many. Out of this line segment, the perpendicular from AB of point P would be single, namely at least PM. Okay, we just considered it as PM. Now, see, we have drawn many, but one line segment would be perpendicular to it. For sure. Correct? Okay, so This perpendicular, in mathematics we define as least length PM as the distance of AB from P. And this is perpendicular. The length of perpendicular from a point to a line is the least distance. Okay, now if the point lies on the point, then the distance from the line would be 0. Obviously, because if it lies, then it can't be just drawn perpendicular. Correct? Now, a circle can have infinitely many chords. In general, the longer chord is near to the center of the circle than the smaller chord. Now, you would ask me why this proof. Okay, I have already told you in maths you don't need to learn anything. Everything is well defined to you. Now just tell me the length of longer chord, why it increases near the circle? Because the length of line segment increases and the points go far away. How is the shape of the circle? The longest chord is diameter, and as we keep on moving towards upward downward, the distance keep on decreasing. Hence, the length of chord decreases when we move away from center and increases when we move towards center. Okay, diameter being the longest chord and the perpendicular length from the center being 0. Okay, equal chords of a circle are equidistant from the center, and this is the theorem which is very important because many questions are being solved very easily with this. So we'll see how this leads to the theorem. We'll prove it. Draw a circle of any radius on a paper. Draw two equal chords AB and CD. Okay. Now also draw the perpendicular OM and ON from the center. Pull the paper such that D falls on B and C falls on A. Okay. You have done it. You may observe that O lies on the crease and N falls on M. Why so? Because OM would be equal to ON. Just do that by using a paper, and if you don't want it, just come with me and we'll prove it mathematically. How we would do that? Okay. Draw congruent circles with O and O dash center and taking chord AB and CD and draw perpendiculars. Now cut one circle disc and put it on the other so that AB coincides with CD. What you would infer? You would infer that O and O dash also coincides, being M and N coinciding, which means that OM would be equal to O dash. Okay, so this is another way to prove it. Okay, third way. From center O, draw two line segment OL and OM of equal length lying inside the circle. Correct? Now draw chords PQ and RS of the circle perpendicular to OL and OM. Measuring the length, you would conquer that the length of the chords are equal. Hence, prove that if chords are equidistant from the center, they are equal in length. Okay, so we have shown you three ways. You can choose whichever you like. Now we'll solve a simple question using the same concept. If two intersecting chords of a circle make equal angles with the diameter passing through their center of intersection, then prove that the chords are equal. So in question we are given that angle OLE is equal to angle OEM. Okay, so it's OE. Okay, also we know that OL is perpendicular to AB and OM is perpendicular to C. Okay, so which means that OLE is equal to OME is equal to 90 degrees. And we also have OE as common side. So we can state that the triangles are congruent by angle side. Which triangle? OLE is congruent to triangle OME. Hence, we can state that this OL is equal to OM. Now, what does OL and OM equal states? It states that they are equidistant chords from the center. Hence, being equidistant, they would be equal in length. We have already proved how equidistant chords are equal in length and vice versa. Correct? So this question was really easy by the use of theorem. For today, we'll wrap up here, and from next part, we will be starting with angles subtended by an arc of a circle. Thank you so much for listening to me. Thank you.